All right, hi guys. My name is John, and I'm super excited to be here today at Mobiconf to talk to you about a topic that I'm very, very passionate about. I also speak a little bit of Polish, so if it's okay with you, I thought I would do a little bit of introduction in Polish, just for fun. So let's see how I do. Dzień dobry, witam w mojej prezentacji. Nazywam się John, jestem ze Szwecji I pracuję w Spotify. Witam. That's good? That's awesome. Happy to hear that. All right, so yeah, my name is John. I am a lead developer at Spotify. If you went to Kevin's talk yesterday, you heard that we have a term that we call chapter leads, which are basically our equivalent of lead developers, managers who also code. And that's what I am. So I manage a team of mobile developers working on both iOS and Android. And we build kind of the core user experience of our mobile applications. So we work on things like browse, search, the running experience, navigation, the settings of the app, things like that that make up the core user experience. So my topic today is UI platformization, and specifically in the context of how you can create view frameworks and use kind of feature system to decouple your code and to make your code easier to manage. So let's get started. What do I actually mean by platformization? It's a good question. It might mean different things to different people, but what it means to me is the kind of the point you reach during your application's development lifecycle where you realize that you're in kind of need for some more infrastructure. Your app might be getting a bit larger, it might be getting more established, you might create new features on top of what you originally planned. And it doesn't really matter if you're a one-man shop or if you're a large company. Platformization is not only something that we do in huge companies with hundreds of developers, it's something that you can do in a small app development company as well. It's basically when you, at this point in time, when you find yourself duplicating code, duplicating efforts, and making it kind of hard for yourself. And there's been some other talks yesterday and today that have touched on these points as well. Basically, you end up with some messy code due to new features being added, and that's completely fine. Basically, what you're looking for with platformization is to set yourself up for success, to make sure that you can leverage things that you've already built to make it easier and faster for you to build new features. So today, I'm not going to present to you a new framework or something that you can clone and import to your app and everything will be great. I'm not going to encourage you to rewrite your app in a new language. It's going to be today just about architecture and also about ways of thinking. So basically, what we were doing at Spotify a few years ago is that we went through a platformization effort. What we wanted to do was we wanted to go from something like this, which is the way our app used to look about 1.5, 2 years ago. And as you can see, well, for the time, I think it looked pretty good. I mean, the visuals are a bit outdated now. This is like the iOS 5, iOS 6 era. But the visual design of the app was a bit messy. It was a bit all over the place. We had some views that had a dark background. Some views had a light background. We used different fonts depending on where in the app you were. We had different colors. We had different call to action buttons. You see one of them there is green, the other one is white. So it ended up being a bit confusing for our users, and as well that we duplicated a lot of code, and yeah, we didn't really have a nice kind of way of working with views and with UI code. So what we really wanted to do was take this kind of a little bit of a messy approach and turn it into this. So this is the way our app currently looks. And of course, like, it's also due to upgrading the design language of the app to make it look and feel more modern, but also the fact that we now have a lot more consistency across the app. So you can see the buttons are all green, the text, the fonts are the same, we use the same margins, we have the same kind of headers across the app, which, you know, makes for a better user experience and also for a better engineering experience, which is really what you want. So today, my goal is to give you 5 tips on how you can platformize your code base, or how any app really can be platformized. And it, again, doesn't matter which size it is. So I thought in order to get things started, I'm going to take you on a little bit of a trip back through time. Specifically, we're going to go back 2.5 years ago. Now, 2.5 years ago in the tech industry, it seems like an eternity. And this is when I actually started at Spotify. It was in May 2013. I had just started. I was hired as an iOS developer. And after a few days, when I had kind of familiarized myself with my new workplace, I started working on my first task. And, as I'm sure you've all done when you're new at a new job in tech, you start kind of poking around the code base. You want to get to know it and see how it really works. So I did that. I started poking around the code base. I looked at the classes. I looked at how things were working. And this is the first time that I met Traxel. Now, Traxel was a pretty okay piece of UI code. It was basically the way that a song, was represented in our app. And as you know, we're a music streaming service, so we have a lot of these in the app. A lot of places where you can see songs and you can play them. So it looked something like this. It basically had this title, subtitle, and a little download indicator. So if you were offline syncing the song, it would actually show up there as well. So my task was to implement some new things in this Traxel. So I started, just to figure out how it worked. And I was looking at the implementation, and I decided to set some breakpoints here and there just to debug it a little bit, just to, find out how it worked. So what I found was that when I set those breakpoints and I was navigating through the app, I found that none of my breakpoints were actually triggered. Nothing happened. So I'm sure you've also, been in the situation before, and this is kind of the big uh-oh moment. This is where you go, uh-oh, something is not right here. You start checking your settings in Xcode, like, am I really doing the right thing here? Or in, Android Studio if you're an Android developer. And it turned out, actually, that the Traxel that I was putting breakpoints in and the Traxel I was looking at was not the one that was placed on the screen. It was not the one being rendered. So it turned out that this Traxel, it was not alone. In fact, it had 6 nearly identical siblings. And yeah, so I started looking at those and I was like, how is this even possible? And I'm sure some of you might be thinking now, did you actually have 7 classes that were named exactly the same? No, of course, neither in Objective-C or Java this is possible. So we didn't have exactly the same name. In fact, what they were different implementations in different parts of the app. So the search feature had the search Traxel, and the artist feature had an artist Traxel. So they all had their different implementation of this Traxel, and they were all slightly different. And that's what kind of you could see before when I showed you these screenshots, is that there were these subtle differences in the user interface simply because they were separate implementations. So if you think that sounds bad and that looks bad, then also what we had was that we also had different cells for different models. So if we were rendering an artist, we had an artist cell. If we were rendering an album, we had an album cell. So if you start doing the math there, where we have different implementations for every part of the app, and we have different implementations for every model, you end up with a few implementations, right? So yeah, none of this sounds very good, and yeah, that's kind of what we started asking ourselves as well. There must be a better way to do this. It can't be that we need to have these many implementations of a table view cell or a list view cell. By the way, I'm sorry if many of my examples will be a little bit more geared toward iOS, because I'm working mostly with iOS, but also with Android. So, I hope you can relate even if you're an Android developer. So it turned out that the reason that we had all these implementations was not just because it's fun, but it was actually because of our autonomy model. So autonomy is something that we really love at Spotify. It's something that we think is great, and that's a core part of the way we run our company. The reason we love it is that, Kevin touched on some of these points yesterday. It makes us really, really fast. It makes us dynamic. It allows us to respond to things a lot quicker. Enables us to get a lot of things done, basically. Well, but as you can see, what happened was that autonomy has kind of led us to this point where we had so many different implementations. And the reason for this really was that our views had become model aware. And I'm sure that you guys have sometimes been encountering this in your own code bases as well, that you tend to mix and match a little bit in your UI and your model code. And it might all be for good intentions. It's a lot quicker to implement. Instead of writing this very nicely separated layers in your application, you're simply writing some easier to use APIs where you can instantiate your views with a certain model. So that's what we were doing. And the reason for this was because each feature team that was working on a part of the app, they only really cared about their part of the app. So when the search team was writing their search feature, they wrote their search track cell because that's what they needed at that time. And they were binding it to their search track model because that's what they got from their backend. So since we were doing this kind of vertical slices of the app, we ended up with a lot of code duplication. So just to give you guys a little bit of insight to how that worked, was that if we looked at the search feature, for example, it would go ahead and create a search results loader. That results loader will call the backend, depending on the query, and then return a track model for track results. And then it would display the data using its search track cell. Now this architecture is, it's okay, but the problem here really was this strong dependency between the model and the view. So there was really no way that the playlist team or the inbox team or the profile team could actually reuse the search code because it was all bound to their model, their way of loading their data. So they had APIs that looked kind of like this. Instead of setting a title and subtitle on the cell, they had something like prepare for reuse with track model, and then actually sending their search track model into the cell itself. Which again, makes for a pretty nice, easy to use API. When you're reusing your cells, you're just sending your model into the cell, and the cell itself can determine how to display that model. It's a nice way of programming, and it's easy, but you kind of paint yourself into a corner. So I said I would give you guys 5 tips today. So I'm going to start with the first one. And the first one is to make sure that you're always breaking the model view dependency. Make sure you don't have any hard dependencies between your view and your models. And this is something that we've probably heard a billion times before. This is always like, MVC 101 really. Like make sure that your model and your view and your controllers are all separate and have, separate concerns. But, as we all know, it's not always super easy to do this in practice. So if we go ahead and revisit our old friend, Mr. Trackcell, how can we actually change this? How can we actually refactor this piece of code to break that view model dependency, to make it a lot easier to reason about and to make it more reusable for the future? Well, we realized that what we really need from our UI is that we needed to be super stupid. We really wanted to create very generalized, dumb views. Views that were uninteresting. We didn't want UI code to get too creative, to do lots of smart things. We wanted it to be short and sweet and simple. So we didn't go ahead and re-implement UIKit. We simply wrote a few subclasses on UIKit classes, like our own table view that just subclass UI table view cell, our own UI switch, which subclass UI switch, etc. Just to kind of add our own styling to it, but that's about it. We let all the logic be moved outside from the view. So the views no longer knew that they were rendering a track. They were just rendering layout information, which is really what you want. So we ended up with the refactored table view cell that we called SBT table view cell. Very simple. So SBT is the class prefix that we use in Objective-C at Spotify. And instead of having these separate implementations for every single model, and every time we created a new model, we would have to create a new implementation, and we couldn't reuse the code across the app, we had a single table view cell. We actually still, to this date, only have one table view cell implementation across our app, which I think is pretty fantastic. And that's an app that like 60 developers or something work on, so I think that's pretty cool. So it basically was one table view cell to rule them all, which was pretty cool. So how the API looked on this table view cell, because we do want some convenience, right, when we're developing. Ash was just speaking about, you want to always work at a high level of abstraction, and I totally agree with that. So you don't necessarily want to set up the cell a lot. That's why these prepare with model style APIs are really nice, because you just have to send your model. So we ended up with creating a very simple API that just stripped all the model information. We focused on what's important to display. It's the title, the subtitle, the image, an accessory view maybe, stuff like that, instead of sending actual model information to the view. So what happened then was that since this information is so general, and since it only has to do with the way the data is being displayed, not about the data itself, we can reuse this all across our app. So we created this class and a few others, about 20 of them or so, and we made a framework that we called Glue. And Glue is, the name wasn't picked only because it's something that you stick things together. It actually stands for something. It stands for Global Language Unified Experience. And I didn't come up with that. If I would have come up with something like that, I probably would have picked a completely super boring name like Consistent Framework or something. I'm not very good with these marketing names. But that's what we came up with. And basically what we wanted with this is we wanted it to be a shared ownership. So when you're working in a larger team, you usually end up having to reason about ownership in one way or another. You might have some developers work on some part of the app, some other developers working on another part of the app, however way you're organized. But we wanted every developer to actually actively work on this. And the reason for that is that we didn't want to end up in the situation we were before, where every developer were off in their own corner writing their own UI views. We actually wanted everything to be contributed into a single place. So everyone was encouraged to make commits to this. We had a very, very open model. And basically what happened was that this allowed us to create a much better sense of consistency across our app. We no longer had all these various implementations of the same view, and views could always be changed in one place. So, if we wanted to tweak some margins or change some colors, we could super easily do so. And this created a lot more consistent behavior for our users and made the app a lot easier to use. Actually, speaking of changing something in one place, we actually went even one step further, and we created something that we call SBT theme. And what that means is that we actually have a centralized place in our app for layout information. So every view doesn't hard code the margins and the colors that it uses. You're not setting up your frames or your auto layout constraints using like 15 or 60 or some other hard-coded float point value. You're actually reading it from a central place. And this was pretty cool because since we were using this theme, we injected it to the initializer to our views. It allowed us to kind of style them all at once. So if you remember, or the slides that I showed you before, where we had kind of this white-black mixed UI, and then we went to the all-black, we actually did that across all platforms in one go. And the reason we could do that was that we actually shipped this code that used the new layout information, the new styles. We shipped that for months before we actually activated it. And it was all due to this theming system. So we could actually have the old theme being used in our production app while testing and working on the new theme. And once we were ready, we basically just flipped the switch and all of our views changed their layout, which I think is pretty cool. So it was a centralized set of colors, margins, and styles. Basically everything that you end up duplicating. Again, we wanted to reduce all the code duplication we could and make sure that we had it in one central place. So for my second tip, my second advice, is that as much as you can, make sure and generalize and collect your UI code into a single shared library. And again, it doesn't matter if you're working on a one-man app or if you're working in a large team. You can always just move your Vue code to a central place. I worked on a lot of projects where we used to structure the code based on the features, like we would have folders in our project that were for every feature, and now instead moving to actually collecting all the UI code in a central place makes it a lot easier to reuse. So now that we have that, let's switch tracks a little bit and talk about something that I've come to really love when it comes to mobile development. And it's something that's been around for ages, but we haven't always been using it a lot on mobile. And it's the concept of view models. Now, some of you might be familiar with view models because it's been very prominent on other platforms, especially I think it comes from Microsoft to begin with. So it's been around for a while. It was part of the Windows UI toolkit. So traditionally, we're used to kind of writing a lot of code in our view controllers on iOS or in our activities or fragments on Android. And of course, we didn't really want to keep doing this because, again, what happens is you start, again, getting these strong relationships between your view or view controller code and your model code. So we wanted some place where we can kind of put all this logic and not have to create these strong dependencies. We also wanted still to be able to have nice and easy to use APIs for building features without having to do this mixing and matching. And that's kind of what view models allows us to do. So let's take a look at how a view model might be implemented in a feature. And I'm going to take the search feature again as example in Spotify. So how the search feature works is it basically, again, goes off to the server, it parses the search request, and it returns a series of models. And those can be different models depending on the search result. So it can be tracks, it can be playlists, it can be albums, etc. So we wanted some easy way to kind of bind this information to the view without, again, making this hard dependency. So for this, we created a one-to-one mapping between our view controllers and the view models. So every view controller also had a view model associated with it. So that's actually where the place you can put all this stuff. You can put all of the things that relate to just this view, just this feature, just this view controller inside of your view model. Has a great advantage of being easy to test, easy to refactor, and you don't end up with these monolithic classes, since there's a nice separation of concerns. And moreover, it also exposes just the data that the view needs. So if we're getting these playlists and tracks and other models, and I'm sure you guys have the same situation in some of the apps you're building, where you have some centralized core data models, but you're not using all of the information that's available in those models in all the views. Sometimes you're just interested in a title, or sometimes you're just interested in an image. So it doesn't make sense to expose all of that to the view layer. So the view model would have APIs that look something like this. You would ask for the title at a certain index. You ask for the subtitle at a certain index. Again, it's mapping the model information to what's actually being rendered on the screen. That's what it's good for. So the view will only know about the things that it actually needs to render, and in a very generalized way. So for my third tip today is that view models, those are totally awesome. I really, really like view models. I cannot really recommend them enough because it makes your view controllers a lot thinner. It creates an explicit ownership of model and view mapping, so you don't have to scatter that across different classes. And actually, we liked view models so much, and we liked it so much the way it allowed us to be productive and fast in coding, and still being able to share all the UI code across all of our app, that we actually even moved them to the back end. And this is something that I'm going to talk about later today. So if you want to hear more about this, you should come to my talk at 3:35. Not a shameless plug at all. So we've done some experiments, and we've actually moved to an architecture where we can send a lot of our layout information from the back end even. But let me move back a bit and talk again about autonomy, because this has kind of become a little bit of a holy grail in software development in general, I think. You always want to be autonomous as a developer. You don't want to have all these dependencies. You don't want to have to go and jump through lots of hoops just to be able to write your code and just to create cool features. And it's a core way of how we work at Spotify as a company. So what we want to do with autonomy is that we want to make sure that we enable teams to move really, really fast. We want to be organized in a way, not only organizationally, but also technically, so that we can actually move very, very fast. And again, without creating these duplicate efforts, duplicate implementations, but we want it to move fast. We also really want to reduce the number of dependencies, not only between teams, but between pieces of code. We're looking for something like a plug-in architecture where you can just mix and match different features, different parts of the app, take away something, refactor it, put it back, create very explicit APIs between part of the apps and explicit connections without creating these hard dependencies. So we wanted also it to be easy to do A/B testing, to do rollouts, to try out new things, put experimental things in there. We wanted things to be available only for internal testers. So, if we were doing an experimental new feature, if someone was just hacking on something, we might not even ship it. We just wanted to try something out. We wanted to create some form of system that allowed us to do this. And we also wanted a very clear sense of ownership. As I touched on before, ownership is very important, I think, because if you have clear ownership, you also have a clear commitment to actually improve a certain piece of code. And you have people who actually know that code very well, which is always a good thing, so you know who to ask. So we ended up with the concept of features. We wanted to take this feature concept to the next level. It's not only something that the users think about, features of your application, but actually something that we can reason about in code as well. We basically wanted to, make sure that we can easily do these things about autonomy that I said before. So we split our app into very, very separate, nice pieces that we call features. And the way we do this is that one team can own one feature, and they can also own many features. It doesn't really matter. But they work on them with a clear sense of ownership. They know that they own these features and they are responsible for maintaining it. And it drives the user experience forward across our whole app. So we're both iterating on existing features, we're creating new features, and we can do it kind of in parallel. So how do we actually end up transferring this idea to actual code? How do we put this into our app architecturally? So if we look at a few features, here are 4 of them. We have the playlist feature, we have the search feature, album feature, and artist feature. So these are all like parts of the app, the pages that you see in the app. So you have a page that represents an artist where you can see artist information, play their albums, play their songs. Then you have an album feature where you can basically see an album, you can see all the songs that are on the album, read some information about it. You have a search feature where you can go off and search our catalog and explore new music. And we have the playlist feature where you can create your own playlist, your own list of songs. You have artwork, description, some metadata, things like that. So these are all 4 very distinct parts and destinations in our application. So this is the way we cut it. So if you have a destination in the app, a page, basically a view controller or a fragment, that essentially became a feature. And they can work together in a very, very nice way. So the way they're set up, at least on iOS, but it's very similar on Android, is that there's separate Xcode projects. So for every single feature, we have a separate Xcode project that lives in a shared workspace. Now, why do we create separate Xcode projects? That seems weird. It's because we really want to avoid conflicts. If you ever tried working 2 people or 3 people or 100 people on an iOS app, you end up with a lot of conflicts in your project file. And we didn't want to have to deal with that every single day. It's a bit of a pain. So we made sure that we have separate Xcode projects for every feature. So it's super easy for the teams to move fast, to add stuff to them without worrying about synchronizing too much. We also actually built separate binaries for each feature. And the reason we did that was that so we can reason about a feature kind of as a mini app within the app. Because we're linking them all with the main app in the end, and they can also declare dependencies, so we can also make sure that several features can use each other's functionality. Since they're separate binaries, we can also conditionally compile them in a very, very easy way. We don't have to scatter these #if pragmas all over the app. We simply can turn on and off a flag in our build system whether we want a certain feature to be compiled in or not. Because if you're only building something experimental, it doesn't make any sense to even compile it into an App Store release. And also by de-risking our builds, because we can just very easily pull something out if we had to. And these features, once they're compiled into the app and linked, they all kind of become one binary. And the features themselves then are objects that are dynamically loaded at startup. So once a user logs in, we figure out what features should this user have through A/B flags and stuff like that. And then we basically just make up the feature set and we make up the app as it should be. So if we take a look at how these things relate to each other, we basically have them sit on top of the glue library that I talked about before. So they all share the same UI framework. They don't contain almost any UI code, these features. They all read from the same library and just use these building blocks that we created in the glue library to make up the user interface that they want to display. We also have things like our SBT data loader, which we open sourced earlier this year, that we use to actually download information from our server. So it's our own networking library that we use over HTTP. And finally, we have a C++ core that we use for stuff like playback and shared logic that should be in the client that all of our features can build on top of. So they all have this shared kind of base that they can build on. And then they can declare dependencies among each other as well. And since these dependencies are declared up front, we can super easily resolve any conflicts and make sure that we have a nice dependency graph. This dependency graph also allows us to improve startup times. So we can make sure that our app loads the features in the best way possible. And finally, this is kind of what makes up our app, the user experience. So let's dig a bit deeper into one of them, just to see how actually this kind of way of interacting between them works. So if we look into the playlist feature, each feature, including the playlist feature, has 2 parts to it. There's an API and there's a private side. So in the private side, you can go crazy and do whatever you want. We don't really enforce a certain architecture for features. They can do really whatever they want, as long as it gets code reviewed and as long as it kind of conforms to some shared standards that we have. But where we're a bit more picky is when it comes to the API, because we want the APIs to be fairly stable and we want them to be easy to use for other developers. So in the API layer, a feature can expose certain features of themselves, such as the playlist feature here is exposing a playlist manager that other features might use to load playlists, put tracks into playlists, delete them, and stuff like that, because you might have other features that want to do that as well. Now what's cool about this, as you can see, is that these are exposed as protocols. And there's a good reason for that. So not only are protocols great for just declaring APIs, but it also means that we don't have to compile all the other features when we're, for example, testing a certain feature. So if I'm working on the playlist feature and I want to run unit tests on it, I don't have to compile the entire app. I can actually just compile the playlist feature, which makes it a lot faster to work on and really, really nice. So what it also allows us to do is to really have multiple implementations of the same protocol without really changing all of the app. Because since we try to keep the APIs fairly stable, we can make sure that the features who interact with, for example, in this case, the playlist feature, they don't have to go around and update their code every month because the playlist guys are implementing a new thing. Instead, they can work on that as a private implementation detail and then still expose that through the same APIs or add new ones. So, protocols, they're really, really good. And there was this great session at WWDC this year about protocol-oriented programming, which I really, really liked. And this is the way that we've been doing things for a while, actually, and we really, really believe in protocol-oriented programming. And the reason for that is that protocols are really, really clearly defined APIs. You don't have to reason about, is this something I'm supposed to use or not? How does this work? Instead, you have just a single header file or a single file where you have the entire API in its entirety. You can also hide all the implementation details. You don't have to expose them to the outside world. And since the implementation lives in the private layer of the feature itself can use it. Internally, they can use whatever implementation they want, but since they expose only the protocol to the outside world, we don't have to go around and update the code every time we make a change. We can even have multiple implementations. So if we want to A/B test a new implementation, or if we want to do a refactor and want to use some new cool API that has just come out, we can do that without having, again, to go around and update every single feature, which is pretty cool. So refactors become a lot less painful. Of course, this is also a lot more testable because you can mock another feature if you want to. You can assert that it will behave in a certain way and assert that your code will interact with it in the correct way and to respond to it in the correct way. So, for my fourth tip, and the second to last one, is that make sure that you break down your code into separate parts with clearly defined APIs. So again, you don't have to go all crazy like we've done and create separate binaries for every single part of your app. That's not what I'm saying. But make sure that you can reason about your code as separate parts. Because if you do that, then you can reason about your app in a very, very more clear way. And it becomes easier to refactor, easier to test, and if you use protocols, instead of injecting actual concrete implementations, it gives you a lot more flexibility. So, protocols and clearly defined APIs is great. So finally, let me talk about something kind of related, which is navigation. So we were talking about a lot today about dependencies and how different parts of an app interacts with one another. And navigation is a core part of this because you want your users to be able to easily navigate across your app, both like if you have a main menu to go into different sections, but also to go from one section easy to another one. So you don't want to, make that hard to implement. So let's take a look at how we kind of used to do this in the past. So traditionally, if we go back to the playlist example, traditionally in your playlist view controller, what you would do is that you would instantiate, if you wanted to open search, for example, you would instantiate a search view controller inside of your playlist view controller and then push it onto your navigation controller. Now, this is all great. Pushing view controllers is something we still do a lot internally. But when you want to do this cross-navigation across the featured border, you really don't want this. Because as I explained earlier, you really don't want to expose these private implementation details of a feature. You want it only to be an API. You only want it to be a protocol. So there's really no way to instantiate something from the outside, which I actually think is a really good thing. So if we can't do this, if we can't create a view controller inside of another view controller, because that again creates this strong dependency between two separate parts of the app, what we wanted to do instead was to create a system where we could just open an intent or fire off an intent and make the system or our apps actually respond to that intent and serve up the correct view controller for that. So the way we chose to go is to use a kind of system standard way of doing things and to use URLs. So all across our app, we're actually using URLs or URIs to navigate. So instead of creating a view controller and instantiating it in another view controller, what we're doing is simply opening a URI. And this is pretty cool because it works both from the outside and from the inside. So other apps can actually deep link into our app, which is pretty nice. It's a nice like extra side effect that we get from this architecture. And also, since everything is decoupled now, we're only dealing about URLs, we can just kind of decouple this dependency, which is pretty nice. So the way it works in our app, you can see here I'm using UApplication, shared application, OpenURL, which is an Apple-provided API that actually goes into your app delegate, where we have a simple registry where each feature can register some URIs that it responds to and even use some predicates to actually determine whether they want to serve a view controller or not. So in this case, I'm opening search using Spotify:/search, and this will actually open the search view in our app. So the search feature is actually registering this URI namespace as its own. So this is the view controller that will be served. So the playlist view controller no longer even has to know that there is a search view controller, how it works, what arguments it takes. It doesn't matter anymore. It just fires off a URI and that's it. So we've found that by using a URL, or really what it is, it's an intent-based navigation system, and I know this is more native on Android, which is pretty awesome, we can actually decrease the inter-feature dependencies. So it's actually pretty easy to implement. It's not something that takes a lot of classes and a lot of code. And basically, what this allows us to do is just fire and forget. A view doesn't need to know exactly what it's opening. It just fires off an intent and lets the system deal with it, which is pretty nice. So we've come to my final tip of the day, the fifth tip. And it's to decouple the parts of your app through a centralized navigation. So instead of kind of having this mess of multiple view controllers pointing to one, you don't really know how it works, you have a lot of dependencies inside these view controllers. If you change an initializer to a view controller, you have to change it everywhere. And again, this is something that we really wanted to avoid. So by using this URI or intent-based navigation system, which is centralized, it becomes a lot more decoupled. And since we're also using the iOS standard way of actually communicating between different parts of an app or even different apps by URIs, it becomes native. It doesn't feel like something we bolted onto the system. It makes it easy to reason about, which is something that we always want to do as well. So we're coming to the end of my talk here today. So I just wanted to summarize for you guys what we went through, all the 5 tips that I made today. And the first one was to break down the model view dependency. Make sure you're not hard coding a certain model structure into your views, because that just makes them impossible to reuse. Also make sure that you generalize your user interface code and collect it in a single place. That's I really advise you to do that, because it's really, really nice. Finally, not finally, but third, view models are awesome. I really, really love view models. Sure, it's a little bit of extra code that you're writing, but the separation of concerns that you get is just really, really nice. Make sure that you break your app down into separate parts with really clearly defined APIs, so that the ways that your different parts of your app interact with each other is just clearly defined, and it's easy to test, easy to mock, and easy to reason about. And finally, decouple the parts of your app through some form of central navigation system. It doesn't have to be URIs if you don't want to. It doesn't have to be intents. But instead of creating these view controllers and hard coding this navigation inside them, and make sure you put it somewhere centralized, because it, again, makes it more easy to reason about. So that was my 5 tips I have today. I have another talk about at 3:35 where I'm going to go into a lot more detail, and I'm even going to do some live coding to show you guys how we can build a view from the back end, which I think is really exciting. So thank you very much for listening. It was great to be here.
Thank you very much, John. Now it's time for questions. And the best questions will win a book or beacons. So
yeah, we have some cool iBeacons here, right?
Yeah.
Oh, that's awesome. Can I ask myself a question? Oh, okay.
I'm not sure. Okay,
so I just want to say before we start the questions, if you guys want to talk to me, my email is right there. You can send me an email. I'm on Twitter at John Sundell. I usually tweet about nerdy stuff like Swift, video games, stuff like that. Sometimes I go off on rants on something. And I also have a GitHub profile. I try to open source as much as I can of the stuff that I make also in my spare time. I'm heavily into Swift, so I have a lot of Swift code on GitHub if you want to check it out. So yeah, cool. Question time.
Okay.
Thanks for the talk. I like that you like bringing all the good practices here, but you should actually name the dependency injection there because you just avoided this
You're right.
term.
Yeah.
The other thing about the navigation, because I do centralized navigation, but within like a very large navigation methods, you're doing the URLs. The question is about the parameters that because when you bring up a new vController or activity, you want to pop up with all the data already there. So you need to have a good caching mechanism already in place, but you haven't told us anything about how it works.
Sure, that's because it's a complete secret. I cannot tell you. No, I'm joking. So it was touched on actually in the previous talk yesterday about React Native, where instead of kind of passing the data around, you just keep it cached, right? So what we can do with our URI system is that just like when you're going to a website, for example, you're using an HTTP URL, you can append arguments to it. So if you want to append like, I'm loading a certain playlist ID or I want to query for a certain search string, you can do that. And then we make sure that all the data that we need is actually cached. But again, we don't want to pass the data as part of the navigation. So that's why we're using this feature system again. Since the URIs come down into the feature system and the features can depend on each other, we can actually, if you're opening search and you want to pass in a playlist, for example, we can actually have the search feature depend on playlist feature and then just query the playlist feature to get that playlist that was already there. So again, you don't have to put all this stuff inside navigation and just pass it along because you don't want these models that just, go around the whole app. You want to have them in one place. So that's how we do it.
So maybe a follow-up. So you have a view models. Let's assume that it is from network. So it's from like screen A. In screen B, there's only part of the view model you can reuse basically the data. So you're rendering like a half of the view,
right?
Probably. With the previous approach, with the traditional approach, you would probably have the full model already in place.
Yeah.
So that makes probably that half of the UI is almost filled. This is what I'm expecting that it can happen and happens.
Yeah. So what we try to do then, if we have something where we need to kind of load some additional data, we try to have kind of like a skeleton view in place. So we fill in the fields that we can, and then we make sure to have some transitions when the other data gets in as well. So we don't get this kind of website feeling with things jump around or create placeholders or something like that. But we really want the navigation to be instantaneous. We want to open the new view controller, fill in the things we can, and then when the other things come in, we just pop them in. Cool. Next question. This is a really good question, by the way. You're on track for winning a beacon right there. If no one can beat you, which I think maybe we'll see.
So hey, thanks for the talk. It was super interesting.
Cool.
Question also about navigation. So this URL thing seems super simple for just pushing view controllers.
Yeah.
So just a question: do you have anywhere in the app where you have some interactive transitions, or when the transition is based on where it comes from, where it goes? And if you do, how does this centralized navigation controller look like?
Right.
It seems like it's going to be a huge mess.
Right. Actually, a very good question. I actually was tasked only like 6 or 5 months ago to make an interactive transition using the iOS 7 API, where you can make like these interactive view controller transitions. And yeah, at the beginning I thought like, shit, this is going to be a bit messy, right? We're going to have to hard code some things. But what we ended up doing was that each view controller can kind of express if it wants to expose a transition view. So the navigation system knows which view controller you're coming from and where you're going. So we can check if the previous view controller wants to expose some transition view, and then it can pass it on to the next view controller and ask it, do you want to use this? So in this example, we were going from a start page into a playlist, and we wanted to kind of move that playlist along. And so what happened was that we would grab that object or that view from the start page, and we would send that into the playlist and ask it, do you want to handle this? And if it returned yes, we would actually start an interactive transition. So yeah, it became actually quite easy and quite nice, because it's all about just handing it over. And since we have the navigation system there in the middle, we can actually have it do that handover for you.
I think we're going to stay on navigation a little bit.
Okay, yeah, sure. I love navigation.
So I really like the idea about sending intents on URLs.
Yeah.
What makes me wonder is, how do you test that a feature A opens feature B still? Because I can understand you can test it on the integration level for each feature. Yeah. But do you have some like UI level tests, integration, business logic tests?
Really good question. So yeah, we do. We have a lot of tests. So we use unit tests internally in each feature to just test that that feature works great. And you can, again, mock the other feature to make sure you're reacting to it. In between features, unit test doesn't make a lot of sense. So there we actually use UI tests instead, and automated UI tests. So there we would just like take the app on a journey, really, and start off and click different parts and see that they assert that they open the correct view. So we have a lot of infrastructure for that, to be able to create these graphs, basically, where you go to search, you search for something, you click on it, you make sure that the artist view gets opened, etc. So and since every view is actually exposing its URI, it makes super easy for that system to actually assert that the right view is opened.
Can I ask a follow-up?
Yeah, absolutely.
So since UI tests are great, but they cost a lot,
yeah.
Have you figured out a way to achieve the same but bring the tests to the lower level?
Yeah, so we started experimenting on iOS. There's a framework called KIF, which allows you to actually write UI tests as if they were unit tests. So that's something that we're doing. But also we're just scaling up our CI to be able, and we're not running all of these tests all the time, because as you say, these are more about just verifying that things still work. So we don't have to run them on every single pull request all the time. We're just running them continuously a few times per day to make sure that we didn't break anything.
Cool.
Yep.
Thanks.
Great question so far, by the way. Yeah, go ahead.
Hi, thank you for a nice talk. The question will be, of course, regarding to navigation.
Yeah, of course.
I saw that you use deep links to manage views, but I think you use a lot of data. You send a lot of data through the deep link. So how do you manage this? Because I think URLs are really long in this programming way. So how do you manage?
Right. So that's what we don't want, right? We don't want it to be like Spotify playlist something : should open, yes. Like, you don't want to have all these arguments, right? So the way we do that is that, again, like I said before, since when we're going through the system, we're kind of dispatching a URI to the navigation system. That then calls the feature system and figures out which feature is responsible for handling this URI. Then the feature can do pretty much whatever it wants and just return a view controller. So this feature can hold dependencies to other features. So for example, if you want to pass data along, all you really need to do is to pass some kind of identifier that this other feature will recognize, and then it can go and kind of query other features to like kind of put the model together. And since this is all done locally, natively, it's super fast. So we don't have to pass these objects around, and we don't actually have to pass a lot of data.
Okay, and it is possible to see some kind of snippet of code of app delegate m file to see how those events are handled.
So as I said before, like, it's actually it's pretty straightforward. Our implementation is very specific to kind of what we do and our business logic, but what really only happens is that you will get this callback that the application was opening a URL. And then we just have a registry with predicates, and we'll just run these predicates against this URL until some of that predicate returns yes. We will then dispatch it to the feature and ask it to provide a view controller. So it's pretty straightforward.
Yeah, and last question about the feature, because as I understood, you have a one centralized module who handle the query, the URL, and after that you have to listen for those queries. So those features are registered in some place.
Yeah, exactly. So like I said before, all these binaries that get compiled, they basically have a central entry point, which is just the feature implementation. And these are all registered in a feature system. Basically, it's called a feature system. And that's what communicates with the navigation system to figure out which feature is responsible for a certain URI.
What about if you have a lot of features? When do you register them? When the app is starting, or you use some kind of lazy loading way?
We do both, but mostly the features that we have a lot of features in our app, like 60 plus or something, but not all of them are used for every single user. So we figure out which features should be for that user, and we just load those features. So it ends up being not more than 10 usually, and yeah, that's pretty quick.
So the conclusion is that you handle, in example, 10 features, or all others are just disabled, right?
Exactly. Yeah.
Okay. Those are my questions.
Or they're lazily initialized when we need them. Yeah.
Okay. Any more questions? Yes.
Wonder if it's going to be about navigation.
Hi, John.
Hi.
Moving away from navigation a bit, but this talk was more about platformizing. But what about the teams across platforms? How do you manage that? Like, say, margins and all for different platforms will be difficult and different. And how strict are you that you have to have the same views, or at least some components which are common? How do you manage such complexity? These teams talk very often together, they sit and design together, or like say when you have a Windows and the view models are much more common there. So that you say to the iOS team, no, you have to do this because this is a good practice and they do it. So how do you manage such kind of conflicting interests?
Right. So I'll start from the beginning. That's a great question. I start from the beginning there. So across platforms, we actually don't want to enforce certain layouts across platforms, because what makes sense on Android makes sense on Android, might not make sense on iOS and Windows, etc. So we want to make sure we have some flexibility there. But we want it to feel like one app. So the designers, they work a lot together, they sit together and they sync. As well as, in our feature teams, we will have an iOS developer, Android developer, so they talk to each other all the time. As well as we have these guilds that span across the entire company for each discipline. So we have an iOS guild, for example, an iOS guild, for example, and an Android guild, and those guilds can synchronize on the platform level. So we have like these synchronization points where we can make sure we discuss those things. But the golden rule kind of here is that if you're making any type of UI code, contribute it to the shared library. It's kind of like an internal open source model where you're just encouraged to send your pull requests basically and integrate it into the library so that anyone can use it.
I'm not going to ask about navigation either.
That's cool. I do love navigation though, but yeah, go on.
Okay, but your application went for quite a long way with a lot of refactoring in the background.
Yep.
I guess a lot of dead code was produced as a side effect.
Oh yeah.
How did you identify the dead code and cope with it?
Really good question as well. So again, like the way we're set up with these protocols and dependency declarations makes it really easy to spot that code because the dependencies are explicit and they're declared. So you don't have this like, oh, is this code being used by some other part of the app? I don't know. Is it safe to delete it? Because you kind of know that up front. It really won't compile if you're using code somewhere else that you're trying to delete. So that's one benefit of it. We do also, we never ever did a rewrite of our app, so we've always been working on the same code base. So what we do is that we, again, just replace the new implementation, we keep the protocol, and then we delete the old implementation straight away once the refactor is finished. So we don't end up with a lot of dead code. But yeah, we're deleting code all the time. I was submitting a pull request the other day which was deleting around like 80 classes. So we do that all the time.
Okay, thanks.
Yeah. Any more questions? Yeah, we have one up there.
Me again. I'll back to navigation. Do you have any caching mechanism to keep the features what was created before?
You mean in between app launches, or in the navigation, like going back and forth in the app?
Both of them, actually.
Okay. So yeah, we do. Each feature is responsible for it. So whatever makes sense to cache, we do cache. We also, since we're using HTTP for our networking, we also use the HTTP cache for things like just caching responses to the backend service. But yeah, it's really up to each feature to cache, because each feature might want to cache some things and throw some things away.
That's work.
Oh, now it works.
Oh, yeah, it's working. What about any reusable? It is possible to reuse the previous created feature for some other things, or any one feature listen for only one event, one type of event?
So one feature can listen to many events, as many as it wants. They can register as many of these URL predicates as they want. So if they want to respond to different intents, that's completely fine. But usually it will only be one. We try to keep them as small as we can, just to be able to reason about them easily, know what they do, and also just to be able to delete them easily once they've run their course.
But it is impossible to reuse for some other things.
It depends, really. I mean, if you're building something on top of something else, ideally you would just create a new feature and depend on the old feature, and then just use the parts that you need and expose that through the API. But you can also build sometimes features get built inside other features as well. So yeah, both of them happen, really.
Yeah, what about if you don't need some feature? Do you remove it, or you just disable and nothing more?
We start by disabling it, and then if it turns out that we really don't need it, we just delete it.
Yeah, okay.
Yeah,
So
you should never be afraid to kill code. It's one of the best parts of being a programmer.
Yeah, okay, thank you very much.
Yeah, you're welcome.
Any more questions? Okay. So which questions?
All right, great questions, everybody. Really, really good. So I'm gonna go with. So I think your questions about caching and how features work together up there was really, really interesting, and as well as your question that you asked in the beginning was really good as well. So yeah, those two are the winners. But really, they were all fantastic questions. So thank you so much for coming to listen to me today, and feel free to discuss with me later. If you want to come to my talk later, I'm going to go into a lot more detail. And also, if you want to hit me up on Twitter and ask me any questions, go ahead. So thank you very much.